Phase change. Why does liquid evaporate? Why does vapor condense? Why do we get phase equilibrium? Why does a liquid cool as it evaporates? Here we have a rigid container which is partially filled with liquid. Above the liquid there is a vacuum. This is not a state of equilibrium, so some of the liquid will start evaporating and turning into vapor. As the vapor forms, the liquid level will decrease, and eventually we will reach a state of equilibrium where the liquid and vapor levels remain constant. At the molecular level, the liquid is a region of high density where the molecules are close together and attractive forces between them are strong. The vapor is a low density region where the molecules are spaced far apart and the attractive forces between them are negligible. At equilibrium, both the liquid and vapor can coexist. Now within the liquid, there will be some molecules which high energy, and the energy will be enough so that it can overcome the attractive forces and go into the vapor. Eventually, we will have a number of these molecules, and this is what we would see as evaporation, where the liquid is changing into the vapor. Now, some of the molecules in the vapor will go and strike the liquid surface, and they will be recaptured because of the attractive forces. This is what we think of as condensation, where vapor turns into liquid. Phase equilibrium is reached when the rate of molecules leaving the liquid equals that returning to it. At equilibrium, the amount of vapor and liquid in the system is constant. Liquid, which is in equilibrium with its own vapor, is known as saturated liquid, and vapor, which is in equilibrium with its own liquid, is known as saturated vapor. The pressure and temperature everywhere in the system are now uniform. The pressure at equilibrium is known as the saturation pressure. The temperature is known as the saturation temperature. The saturation temperature is also what we think of as the boiling point of a liquid. The energies of molecules in the liquid will follow a certain distribution. They are not all equal. If there's a minimum energy required to leave the liquid, then there will be only a certain number of the molecules which have an energy greater than this. Their energy will be enough to overcome the attractive forces, to break free from the liquid, and to go into the vapor phase. The temperature of the system is increased. Then the number of molecules whose energy exceeds this minimum energy is going to increase. So you will have more molecules escaping from the liquid, and the number of molecules in the vapor phase is going to increase. The pressure in the vapor is therefore going to increase. So the saturation pressure increases as the temperature increases. Now, if we look at the molecules that are leaving the liquid, these have higher energy than average. So the molecules leaving the liquid have higher energy than average, which means that the average energy of the liquid actually decreases. The liquid left behind therefore cools down. The energy which is carried away is what we call the latent heat. To summarize, high energy molecules escape from the liquid and become vapor. Low energy molecules are recaptured by the liquid surface. Phase equilibrium is reached when the rate of molecules leaving the liquid equals that returning to it. Molecules leaving the liquid have higher energy than average. The liquid is cooled when evaporation occurs, and the energy carried away is known as the latent heat.